problem 1 on the MMPC part 2 of 2018 was this geometry problem. So the text of the problem had a much longer description. It labeled all the points and it even labeled the arcs of the circle. But just for the simplicity of presenting it, I'll leave it without a lot of labels. So we have a unit square and we have quarter circles. From these two vertices, the quarter circle that goes from corner to corner, so radius 1 quarter circles. And then we have one more quarter circle from the southwest corner that has radius x. And we take the intersection points and we draw straight lines. And we're defining this function x as the ratio of the area of this thin shaded region to this thin shaded region. And the question is, find that ratio when x equals 1, and well, then find the function in general. So it seems like if we solve part 2, we can solve part 1 by just plugging in 1 to whatever formula we have. So let's just try and think about that. Let's not do part 1 unless we're kind of stuck running out of time and hoping part 1 is easier. We can get a couple points out of it. So it seems like it seems like what's going to be important is calculating, or at least thinking about, these angles of the sector. And you guys probably know how to calculate the area of this kind of region. We would take the area of the full sector and subtract off the area of the triangle. So you might start thinking about how do we calculate the area of the triangle? Do I need to, I could write it as 1/2 x squared sine theta for the area of the triangle. So let's even write that down. You might start to think, how do I even calculate this area? And if I had a measure of this angle, then I'd be able to calculate it, right? It's going to be x squared times theta over 2 minus 1/2 x squared sine theta. So if I can get theta in terms of x, then I might be able to write down the area exactly. And then I might be able to find this angle and do something similar, except this region 1 is a little bit easier because the radius is fixed at 1. But still, it's going to be difficult to calculate theta as a function of x. And even when I get that, if I start thinking about a ratio here, it's, I don't actually care about the area of 2, I only care about the ratio. So let's think about these angles first. Okay, so I'm looking at this picture and I'm seeing a couple of shapes. I'm seeing a kind of kite shape here. I'm seeing this angle and this angle, and I'm seeing a lot of isosceles triangles. So what I want to do is I want to try to label as many angles as I can. I want to try and chase this one angle theta. Potentially I can calculate this angle in terms of theta if I so-called chase these angles all the way around the circle. All right, I have right angle from the square, so and I have symmetry. So these two angles are equal, and they're both equal to pi over 2 minus theta, whole thing divided by 2. So each of these angles is pi over 4 minus theta. theta over 2. That could be useful. Call this angle phi, and now I'm going to think this phi is coming from the center of this circle, whereas this angle has the same two endpoints on the circle, but it's made between the tangent and the secant line. So I think we're going to have to use this fact. Okay, so you should remember this picture from geometry. If you have a sector, then the angle from the center of the circle will be twice the angle from, this isn't necessarily directly across, right, for any other point on the circle, and the angle between the, oops, I drew that too long. And the angle between the tangent and the secant line cutting off the same arc of the circle. Right? These two angles are going to be the same. You can kind of think of this one as the limiting case, as this point moves all the way to one of the two edges of the ray. So you could reprove this, I guess, pretty quickly using the fact that the radius and the tangent are parallel, and the fact we have all these isosceles triangles. But I think this is a fact basic enough in geometry. You don't need to reprove it. We use that, and we can see that. If I'm interested in this angle is going to be phi, and this little angle here is then going to be half phi. I'm running out of colors. This big angle here, right? This cuts off like 270 degrees of circle. So this big angle here, that would be 3 pi over 2 divided by 2. So this big angle here is 3 pi over 4. Okay? And now we're gonna be able to connect phi and theta by chasing around this quadrilateral. So it doesn't matter that the quadrilateral is not convex. The sum of the angles is still going to be 2 pi. And we know most of the angles. So of course this angle here is pi over 2. This angle here, right, this obtuse, this interior angle here is going to be 5 pi over 4. And this angle here, well, we labeled it down there. So what we have is, I'll write it down in blue. We have phi over 2 plus pi over 2 plus pi over 4 minus theta over 2 plus the big one, 5 pi over 4, should all equal 2 pi. And and I see something interesting here. We're going to get pi over 2, that's 2 pi over 4, 3 pi over 4, 8 pi over 4, right? All of these fractions of pi add up to 2 pi. So this simplifies down to phi equals theta. That's great. That means that region 1 and region 2 are similar. They're similar, and the length ratio is x. So I would write these facts vertically on the sheet of paper, but on the whiteboard, if we have that they're similar and they have a length ratio of x, then they have a area ratio, and so area ratio x squared. And that's what the function was looking for, the area ratio, and it's a very simple function, x squared. And in particular, r of 1 equals 1. So if I drew the picture with x equal 1, I guess we'd have the same. It would probably be easier to show a different way, that the two regions would be congruent. Okay, that's the geometry problem. I'm glad we didn't have to actually calculate theta or x or any other length. It turned out quite nicely by chasing those angles around. If you're going to write this down on your MMPC, this probably, like, take a photo of this and put it in your MMPC. It's probably not a 10-point solution. You probably have to write words when you write down as a sentence using the vertex labels and naming the angles, right? So if this was like, I forget what labels they used. If this was P, A, D, you'd have to write down something like angle PAD equals pi over 4 minus theta over 2. You'd have to explain where all these numbers came from. But even if you just wrote them down, I think it's fairly clear. I mean, yeah, the important step from geometry is realizing that this angle is half of this angle because of this angle measuring theorem from a circle. So, okay, so one geometry problem in the books.